across age. Thus far, my samples have ranged anywhere from 8 years old to the mid-60s, male, female, different dietary types, different locations across the country, one overseas from China. This is the extent of the human samples thus far. You'll also see a paper on the subject of animal blood, some canine blood, some dog blood that had been looked at also. But I won't go into that tonight, but it extends beyond the human condition, it appears. Okay, so those are the photographs I wanted to show you, and then the last set of photographs I wanted to show you would be a set of what I would regard as reasonably normal looking and reasonably healthy looking red blood cells. And that this is generally the type of thing that we're seeking when we examine our blood. Again, I'm not a medical doctor, I'm going by pure research, and you can study the books. Go ahead and get your photographs of blood under the electron microscope, however you want to get them, study them, look at their physical properties, and then contrast the two styles that I'm showing you, and ask yourself, do you think what I just showed you prior to this was normal? And is that acceptable to you if such a condition were to be pervasive in the human condition? That's the question I would ask you. I won't go into great detail here, other than I will mention that the blood from this particular individual has looked in the past every bit as, call it, degraded in form and structure as the previous examples. In other words, the blood of this particular individual looked like crap, I guess we could say, in more common language, in the past. Every bit as bad as everything you saw earlier. And I'm not offering any kind of magic cures here. In fact, I'm inviting the medical community to become involved in that which has been learned and that which needs to be done. But what we can say is that certain strategies that have been outlined in my papers have been applied to this individual over a period of time. Notably the consideration of the acid and alkaline state of the body and the application of antioxidants on a fairly significant scale. These are certainly two primary factors that have been involved in this particular individual. And this individual has, I would say, shown rather significant and considerable improvement, at the very least in terms of the geometry, uniformity, integrity of these cells. Again, there's no magic bullet here. One of the things I've also learned here, it's been quite a surprise, but the normal cycle of blood cells is about 3 months. And when I first started this work, I had just the perception that, no matter what a person did, it might not be until 3 months that they could see any kind of change at all. That was just a hypothesis based upon the fact that this is the life cycle. What I can say from direct observation and research is that this is not the case at all. And I have seen the blood go through a radical transformations, I would say, within about a 3-week period. So the condition of the blood can change quite rapidly from what I've seen. And that means both ways. And I have seen it both ways. Just as I'm showing him some photograph here that I would regard as, quite acceptable, at least from my standpoint of what I would expect to see in terms of, shape, size, and all this kind of business. I have seen these same cells degrade themselves significantly over a 3-week period as well. So there's no easy answer here, and it's much more dynamic maybe than we might want to admit. But I'm offering this to let you know that there are real prospects available to us for further research, And the Institute exists in part for this, and hopefully there will be others involved. But I believe there are real prospects for the improvement in this particular condition that has been observed, and that the strategies that have been outlined thus far form an initial foundation upon which these studies that I would suggest could be developed. So how's that for being diplomatic on that one? And I'll just give you a couple more photographs here. And those are two photographs. Okay? Now, that's the end. And we're, as usual, I'll run out of time. But, you know, if you're willing to come back, I'll be back another time. I do have another section I wanted to get through, but I'm also not going to hold this longer than we said. Here's a time where we could have questions, and let's not worry about the next part, because we may need another whole hour for that. But nevertheless, this is a time where we could throw out whether or not there are any questions on this, preferably on the specifics of what we have talked about tonight, okay? And I'll give a little clue, and other folks will learn pretty soon, but if you start throwing out questions about religion, it's over for you, okay? If there are questions, I would like to have them focused on the subject material that we have presented, or be directly relevant to that which concerns all of us here tonight, and not some individual personal need. So if you like, or you're willing, and you have a question or two, I'll be glad to try and entertain you and help out the best I can, and see what we can do. Is that okay with everybody if we take that on for a couple minutes? And be aware, I'm not able to keep up with the dialogue, the chat dialogue that goes on in the background while I'm talking, because I'm too busy with my side. I think Lori let you know that. But now I will be looking at that chat window for any questions that you have, and we'll see if I can help them. Okay, the first one I have here is from, and I hope you don't mind if I have a little cup of tea. It's been 100 degrees out here for the last week, and I actually had a big jar of iced tea, but I reduced it to a glass so that it wouldn't overwhelm the camera. So the question is, how long did it take to demonstrate the filaments in the first photograph after the swishing? Well, let me see if I understand this correctly. But the filaments come directly. I mean, they are directly visible. This is not something that grows after the wine is expelled from the mouth. These are physically visible at the first photograph. Those are direct. Okay, great. Okay, so that's what happens there. And then the next question I have is, has anyone seen microscopically, I assume is what we're trying to say, little monster-like parasites? Well, I'll try to give a direct answer first, and then we go into nuances later. Monster-like parasites, I say no. All right, I'll make it simple now, and then because there's obviously a connotation with the word monster, and my work is very well, let's say, defined and described. I probably have scores to hundreds of photographs of repetitive structures, very identifiable repetitive structures. And that's what the focus of my work is, and that's what I want our resolutions to focus on over time. And any claims of things that cannot be substantiated directly with the photograph or direct evidence, I really don't have any particular involvement with. And at this point, I'll have to throw the monster term into that category. And that's not meant to be flippant. It's just there's a connotation with that word that really is not appropriate in terms of what is being described at this level. We could call it, a monster issue that's before us here, but not in terms of structures. Okay. This is from Nicholas, and Nicholas is asking, is there a time sequence in the red blood cell photograph? Do these black parasites leave the red blood cells, or do they stay embedded in the membrane? Well, let's go first on a time sequence. No, there's not a time sequence in the sense that these photographs were